Hello viewers, in this session we are going to discuss an important problem from differential equation. So here we are going to discuss this differential equation which is reducible to variable separable form, right? So let us see how we can reduce this differential equation into variable separable form, and then we can find out the general and particular solution of this equation, right? So let us here make use of the method of substitution to transform this differential equation into a variable separable form, right? So here we are going to make use of this substitution. Let us take v is equal to x minus y minus 1. So here we'll first assume that v is equal to x minus y minus 1, where v is some function of x. So let us now differentiate v with respect to x. So we have dv over dx is equal to d by dx of x. Then we have d by dx of y, and 1 being a constant, so the derivative of 1 with respect to x is 0. So we have dv over dx is equal to 1 minus dy over dx. So now let us write the value of dy over dx in terms of dv over dx. So we can now write dy over dx is equal to 1 minus dv over dx. So now let us transform this equation in terms of v and x. So here we have v is equal to x minus y minus 1. So we can now write here v square. Then for dy over dx, we have 1 minus dv over dx, and this is equal to 1. So now we can write 1 minus dv over dx is equal to 1 over v square. So from this equation, we can now write dv over dx is equal to 1 minus 1 over v square. So now we can write dv over dx is equal to v square minus 1 over v square. So now from this equation we can see that here we can separate the variables v and x. So separating the variables v and x, we have now here v square over v square minus 1 dv is equal to dx. So in the left hand side we have the variable v, and in the right hand side we have the variable x. So let us now integrate both sides. So this is a variable separable form of differential equation. So integrating both sides, we have v square over v square minus 1 dv, and here we have integral dx, and c is the constant of integration. So now to find out the integral of v square over v square minus 1, let us write the numerator as v square minus 1 plus 1, and here we have v square minus 1 and dv. Here we have x plus c, right? So here we are writing v square as v square minus 1 plus 1, because here 1 and minus 1 get cancelled. And let us now split this integral into two parts, that is v square minus 1 over v square minus 1 plus 1 over v square minus 1, and here we have dv and x plus c. So here v square minus 1 and v square minus 1 get cancelled, and here we have 1 plus 1 over v square minus 1. So 1 can be written as 1 square, and here we have dv and x plus c. So now we can easily find out the integral of this function, because here the integral dv, and here we have the integral dv over v square minus 1 square and x plus c. So here we have simply v, and here to write the integral, we have to make use of this standard result, that is dx over x square minus a square is given by 1 over 2a, and log of absolute value of x minus a over x plus a. So here this integral is of this form. Here the variable is x, here the variable is v, and for a we have 1. So here we have 1 over 2 times 1, because a is 1, and then we have log of v minus 1 over v plus 1, and here we have x plus c. So now substituting the value of v as x minus y minus 1 in this expression, we have x minus y minus 1 plus 1 over 2, and here we have natural log of v minus 1, v is x minus y minus 1, then we have minus 1, and x minus y minus 1 plus 1, and in the right hand side we have x plus c. Now this x and this x get cancelled, and we can take these two terms to the right hand side. So here we have simply half and log of x minus y, and here we have minus 2, and here 1 and minus 1 get cancelled. Here we have simply x minus y, and here we have y plus 1 plus c, right? So now let us multiply both sides by 2, so that we can get rid of this 2. So here we have log of x minus y minus 2, x minus y, and here we have 2y plus 2 plus 2c, and here c is the constant of integration. So now we can see that 2 plus 2c is a constant. So let us replace 2 plus 2c by some other constant, say c1. So let us write c1 is equal to 2 plus 2c. So we have now a log of x minus y minus 2 over x minus y, and here we have 2y plus c1, right? So this expression gives us the general solution of this differential equation, and we can also write this expression as here we can write log, and here the base is e. So here we are now using the notation logarithm of mod of x minus y minus 2 over x minus y to the base e, and here we have 2y plus c1. So now we can also write this expression as absolute value of x minus y minus 2 over x minus y is equal to e raised to this quantity, that is 2y plus c1. So here we can make use of this definition of logarithm, that is logarithm of b to the base a is say k, then b can be written as a raised to k. So now here we have e raised to 2y plus c1. So we can also write it like this: e raised to 2y times e raised to c1. Now e raised to c1 is another constant. So let us replace e raised to c1 by some other constant, say c2. So here we have c2 is equal to e raised to c1. So here we have now e raised to 2y times c2, that is c2 times e raised to 2y. So now we can also write the general solution of this differential equation as mod of x minus y minus 2 over x minus y is equal to c2 times e raised to 2y, where c2 is some constant. So now with the help of this expression or this general solution, we can find out the particular solution of this differential equation when we are given this condition, that is y of 4 is equal to 1. So this is the value of x. So we have x is equal to 4 and y is equal to 1, right? So let us substitute these values in this expression to get the value of C2. So we have here absolute value of x minus y minus 2 over x minus y. So we have 4 minus 1 minus 2 over here we have 4 minus 1, and here we have c2 times e raised to 2 times 1 because y is equal to 1. So here we have now 4 minus 1 is 3, 3 minus 2 is 1, 4 minus 1 is 3, and here we have c2 times e square, right, where e is the exponential number. So the mod of 1 over 3 is simply 1 over 3. So we have c2 times e square. So c2 is now equal to 1 over 3 times e square. So this is the value of this constant c2. So now let us substitute this value of c2 in this expression. So we have now mod of x minus y minus 2 over x minus y, and for c2 we have 1 over 3, and here we have e square, and here we have e raised to 2y. So now here the bases are same. Here we have e, here also we have e. So taking e square to the numerator, we can now write this expression as x minus y minus 2 x minus y, and we have 1 over 3 times e raised to 2y minus 2. So this is the required particular solution of this differential equation when this condition is given. So now here we have in the left hand side the modulus function, right? So using this result, that is say mod of a is equal to b, then we have a is equal to plus minus b, right? So here we can now write x minus y minus 2 over x minus y. So removing the mod function symbol here, we have here in the right hand side plus minus 1 over 3 and e raised to 2y minus 2, right? So now from this expression, we have two statements. The first one is x minus y minus 2 over x minus y is equal to positive 1 over 3 e raised to 2y minus 2, and the second one is x minus y minus 2 over x minus y is equal to negative of 1 over 3 e raised to 2y minus 2. So we have from this expression two statements. The first one is corresponding to the positive sign, and the second one is corresponding to the negative sign. So now here we can easily verify that this statement cannot be true, because this expression does not satisfy these values. that is x is equal to 4, y is equal to 1. So if we take x is equal to 4 and y is equal to 1 in this expression, here we have 4 minus 1 is 3, 3 minus 2 is 1, and here we have 4 minus 1 is 3, and here we have minus 1 over 3, and here we have e raised to 2 times 1 minus 2, that is minus 1 over 3, and e raised to 0, e raised to 0 is 1. So here we have minus 1 over 3 times 1, that is minus 1 over 3. So we are getting a false statement here. 1 over 3 is equal to minus 1 over 3, which is not true, right? So here we can discard the negative sign and will retain the positive sign. So the particular solution of this differential equation can now be written as x minus y minus 2 over x minus y is equal to 1 over 3 e raised to 2y minus 2 from this statement. So this is the required uh, particular solution of this differential equation, because this expression it satisfies these values. X is equal to 4 and y is equal to 1. So this is how we can solve these kind of equations which can be reduced to variable separable form.